Good day, grade 10 learners. Welcome to our mathematics revision lesson. We're going to revise paper 2. Right, this lesson is brought to you by the Gauteng Department of Education. I am Sikhulile Ncube. Right, how are you? How is your day, grade 10s? Hey, this side is hot. It's hot these days, but there's nothing we can do. Life goes on. Okay, so we're going to look at paper 2 today, and we're going to enjoy the lesson. You see, I also have my pen here with me. I have my calculator here. I'll be doing a lot of mathematics today. I really hope that you have your paper, your books there with you, your pen, your pencil, your calculators, you have them with you there, so that when we do things, you're also doing your calculations. Don't just listen. You won't learn anything when you do that. Okay? Right. You're listening to mathematics like you're listening to music. It won't work. It won't work. We do mathematics. We do mathematics. So if I give you a chance to do things, do that. Don't even wait for me to tell you to do things. Okay? You see a question, just do it. Just don't wait for me. Just do it and then confirm your answers. Okay? Right. So what are we going to do today? Let's just look at the structure of our paper. Right. We've done Euclidean geometry grade 10s. You remember that? The midpoint theorem, we did that. Okay? And then the properties of quadrilaterals, we did that in the previous lessons. The two last lessons, we did the Euclidean geometry. So we're not doing this one today. So we're going to concentrate on analytical geometry, and then trigonometry and statistics. Okay? But usually the arrangement of questions in the question paper is just the other way around. You see, we started with analytical geometry, trigonometry, and statistics. Now, paper 2 usually start with statistics. So I'll follow the structure of the paper. Remember, every question that you see here today is a past examination question. Okay? Right. So it's easy. Very, very easy. Okay? Right. So these are some of the common errors that we encounter. Right. Failure to integrate topics. What is to integrate? Okay? Right. Now, we are doing paper 2. What are the topics for paper 2? You find Euclidean geometry, you find trigonometry, you find statistics, you find all those things. Paper 1, what do you find? Mainly algebra. You can't say that there's no algebra in paper 2. There is a lot of it. Okay? So we're going to use a lot of algebra there in paper 2. You may find even simultaneous equations. Okay? So, and the other thing, when you look at maybe the diagrams that are given for analytical geometry, it does not mean that you can't apply trigonometry there. You'll see some of the questions there is a coordinate geometry question, but you'll apply trigonometry. So mathematics is mathematics. We just break it into pieces so that you can understand it better, but think holistically so that it's the whole subject. Okay? Right. Now, that is the first problem there. Failure to apply algebraic manipulation skills, resulting in unnecessary loss of marks. Algebra is the backbone of mathematics, and we've done a lot of algebra, so you must be knowing how to solve the equations. Don't lose marks unnecessarily. Okay? Right. Failure to read questions diligently. Okay? Candidates overlook critical information contained in questions. When you are reading a question, highlight the important points, the key points that you're going to use to answer the question. Remember that. Don't rush to the questions. Answering something maybe you're not even sure of. Make sure you understand the information before you do anything. Okay? Failure to draw graphs, read off from graphs and interpret graphs. It's another problem. Failing to interpret graphs, reading from graphs is a problem. Right, okay? Failure to use the gradient, distance, and midpoint formulae. When it comes to coordinate geometry, these are the three that we have done. Gradient formula, distance formula, midpoint formula. Remember those. You won't find a question paper without this. That won't be a paper 2 question if it's like that, okay? Every paper 2 paper has this. When it comes to analytical geometry, you're talking about the gradient, you're talking about the distance, you're talking about the midpoint. Right, let's go straight to our question. Read the question. 19 girls. It's very important. Because if they should have said some girls, if they didn't want to say why 19, it means somehow we have to use it. Right, we're required to complete a puzzle as quickly as possible. Their times in seconds. This is the time in seconds. Right, were recorded and shown in the table below. Identify the median time taken by the girls to complete the puzzle. Understand the information. Even this information, sometimes people don't understand it. They think that maybe these are marks, 14, 15. They think about marks, but you're told that this is time in seconds. You must make sure they understand. So it means is out of these 19 girls, one girl finished the puzzle in 14 seconds. Another girl finished the puzzle in 15 seconds. Two girls finished the puzzle in 16 seconds. Two girls finished the puzzle in 17 seconds. Two finished the puzzle in 18 seconds. Three finished the puzzle in 19 seconds. 1, 20 seconds, 2, 20, like that. Understand the information. Now, I want you to try to answer this question in 1 minute. Let's try that. You must get this 1 mark. Let's find the median time taken by the girls to complete the puzzle. 1 minute. Right, welcome back, grade 10s. Did you get the answer? I really hope so. Right, if you're still working, doing your calculations, continue. Don't wait for me. Just continue doing your calculations, okay? Right now, identify the median time. The median time. This time here is between 14 seconds and 29 seconds. So it means your median time should be halfway between those two, between 14 and 29. Okay? I found people getting answers like 10, they say it's a median, but you don't see 10 there. The minimum time is 14, the maximum time is 29 seconds there. So you can't get the median value, which is out of that range, which is below 14, which is above 29. You can't. It must be between those two. Please take note of that. Right, now, again, you'll be given a lot of items in a data set, so you cannot do the thing of counting. We have a formula that we use as mathematicians, that of finding the position of the median. Not the median, the position of the median. So median position is what? Median position. Please don't forget to write that. Write median position, not median. Median position is equals to half of n plus 1, where n is the number of data items there. Our n is 19, so the median position is equals to half of 19 plus 1, which is 20. 20 divided by 2 is 10. So what is the median? Another common mistake. You'll find learners saying the median is 10. But 10 is not even within that range of 14 to 29. You see that? So this is the median position. The median is in position number 10. Right. The other thing that I forgot to emphasize is that these values are arranged for us already. If they were not arranged, we're supposed to arrange them in an ascending order or even descending order, but usually we use the ascending order. Because everything is arranged for us, check the mark, there is just 1 mark. Otherwise, if they're not arranged, it means you're going to get what? This question is going to be 2 marks. Okay, so the median position is 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, very good. So the median time the median time is equals to 19 seconds. That's the average. That's the average. So the average learner should take about 19 seconds to finish the puzzle. The slowest learner took 14 seconds. The fastest. You see, that is very important to understand the context. Now I can't say the slowest because 14 is the smallest there. That's the fastest because now it's taking shorter time. The fastest learner 14 seconds to finish the puzzle, and then the slowest learner 29 seconds to finish the puzzle. Okay, so it is very, very important to understand the context of the question. Right, determine the lower and upper quarters for the data. Determine the lower and the upper quarters for the data. So some of the things I'm going to be giving you so that you try, and then some of the things I'll just explain them so that we don't lose a lot of time. Right, what's the formula for finding the lower quartile position? Right, Q1, which is, remember Q2 is what is the median. Let me write it somewhere here. Q2, we got that is 19 seconds. Right, okay, let's find Q1, the lower quartile. Q1, the lower quartile. Right, the Q1 position, not the Q1 lower quartile time, no, the position. 1/4, and then we know that our n is what? Is 19. 19 plus 1 is 20. So 19 plus 1, which is 5. Okay, so it means position number 5 is lower quartile. And then let's do our upper quartile. So Q1 is equal to 5 seconds. Okay, all right, and then Q3, which is the upper quartile. I'm writing a funny spelling here. Right, upper quartile, position. You see that? So the upper quartile position is what? 3/4, n plus 1. So our n is 19, so it means it's going to be 15. So the upper quartile is position number 15. What did I write here? A big mistake. I'm talking about the mistake that I'm talking about here. This is very wrong. Okay, this is very, very wrong. This is the position. I'm making the same mistake that I'm talking about. Okay, so that 5 is the position. Now let's find the lower quartile. It's 1, 2, 3, 4, 5. So the lower quartile is 17. Okay, and then the upper quartile, number 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should have counted from 10 there. Right, 11, 12, 13, 14, 15, 22. That's the upper quartile, 22 seconds. Okay, right, 22 seconds. Right, very good. So now we have found our lower quartile and upper quartile. We already have our what? Our what do you call this? Our median. Okay, right. Draw a box and whisker diagram to represent the data. Right, now I'm going to, let's write our things down that we got. We got what? Q1 was what? I forgot now. Was it 19? Yes. Q2? Q1 was 1, 2, 3, 4, 5, 17. Q1 was 17. And then Q2 was 19. Okay. Q2 is equal to 19. Then Q3 is equals to, what was it? 1, 2, 3, 4, 5, 22. Okay. Right, now I want you to try to draw the box and whisker. Let me give you the scaling that you can use. Okay, I'll draw the scaling that you can use here. Let's say this one is 12. And then 16. And then 20. And then 24. And then 28. And then 32. Okay, right, now let's try that. So I want you to try to draw a number line like this, and then you draw your box and whisker. I'm going to give you 2 minutes. Let's try that. Right, welcome back, grade 10s. Did you manage to draw your box and whisker? A box and whiskers. Okay, right. A box and whisker summarizes what? Or represents what? What is this box and whisker? It gives us the 5-number summary. The box and whisker will give us what? The 5-number summary. What are those items? We have the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. Okay, so what is our minimum value? Is 14. Okay, so 14 is between 12 and 16 is here. So you draw your line like that. That's your lower quartile, that's your minimum value. Right, you go from your minimum value, we go to the lower quartile, which is 17. Right, 16 and then 20, this is 18. So it means 17 should be here, between 16 and 18. Okay, right, and then we go to the median, Q2, 19. 19 should be here, between 18 and 20. Okay, and then we have the upper quartile, which is 22. 22, which is here. Okay, right, that is 22. And then the maximum value is 29. The minimum was 14. The maximum value is 29, which is here. Remember that. Okay, right, then we have our whiskers at the end, like the cat has got whiskers. Right, and then we have the box. You see, this is the box and the whisker. Right here, you indicate your 5-number summary. So here we have 14. We have lower quartile, which is 17. Why did I write this 0? Right, 17. We have our median, which is 19. We have our upper quartile, which is 22. And then we have our maximum value, which is 29. Do you see that? That is box and whisker. Let me explain some of the things that we get from the box and whisker before we go to the next questions. Right. The box and whisker divides, let me just draw something like this. Divides your data set into 4 equal parts. Right. Between the minimum and the lower quartile, that is your 25%. Okay, and then between the lower quartile and the median, that's another 25%. And then between the median and the upper quartile, that is 25%. And then between the upper quartile and the maximum value is 25%. Okay, right. And then the distribution of data may be different depending on the ranges in a given section. Okay, we'll discuss about those later. Right, now if my mark, or in this case we're talking about time, if my time is say 17, it is the, let me use another color. Right, let's say the mark is 17 here, which is the lower quartile. What is the meaning of that? It means 25% of my colleagues are faster than me because they have spent less time doing the puzzle. So it means 25% is below the lower quartile. And then 75% is above the lower quartile. Do you understand that? Let me use the upper quartile now in the example. Right, let's say we have, my mark is actually 22, which is the upper quartile. What is the meaning of that? It means only 25% were slower than me because they took more time than me. So, and 75%, okay, were faster than me. Okay, so that's the meaning of the quartiles. And then the median, remember, is the second quartile. 50% below and then 50% above. So when I'm saying your mark is the median mark in the classroom, it means 50% of your colleagues got below your mark, and then 50% of your colleagues got above your mark. If your mark is the median, is the upper quartile mark, let's say your mark is 60% and it is the upper quartile, it means 25% of your colleagues got above 60% and 75% got below. Okay, so that's how you interpret what the box and whisker. Okay, right, it's a 5-number summary. Also, it can give us how the data is distributed like that. Okay, right, the 5-number summary for the time taken in seconds by 19 boys, now it's boys, to complete the puzzle, the same puzzle, 15 minutes up to 30 minutes. That's the minimum and maximum. Lower quartile 19, upper quartile 26, and then median 23. Okay, calculate the interquartile range for the time taken by the boys. 2 marks. This one does not even need 2 marks. Let's say 1 mark. Okay, let's try this one in 1 minute. Okay, right, calculate the interquartile range. 1 minute. Let's try. Welcome back, Cretans. Right, welcome back. Right, remember our WhatsApp line, Cretans, 064 748 8913. 064 748 8913. Right, I forgot to remind you at the beginning. Please send us about your WhatsApp, and then if you've got any questions, you want to give us input, you want to show us your work, let's do that. Okay, right, how do we find the interquartile? interquartile. Okay, inter means what? Between the quartiles. Right, now interquartile range means the difference between Q3 and Q1. Right, we usually use I for interquartile range. Okay, IQR for interquartile range is equals to Q3 minus Q1. Right, what is our Q3 here? It is 26. What is our Q1 is 19 is given. So the interquartile range is going to be 26 minus 19. You get such questions in mathematics. Do you see that? Very, very easy. Very, very easy. Okay, just remember what the interquartile range is. Now, this is the data that we're given. And then now they're saying that if only one boy took 19 seconds to complete the puzzle, what percentage of boys took at least 19 seconds to complete the puzzle? It is very, very important. When I'm saying it took me at least 2 minutes to get to the shops, at least 2 minutes. Well, let me use this example. Okay, at least 5 learners. I want 5 learners, at least 5 learners to come to the front. It means what? 5 learners or more must come to the front, isn't it? If I say I want at most 5 learners, it means it can't be more than 5. So you understand these words: at least, at most, okay, the maximum, the minimum, understand those. So now, if only one boy took 19 seconds to complete the puzzle, what percentage of the boys took at least 19 seconds to complete? So it means 19 seconds or more. So it means we're here and you're looking at 19 seconds or more. How many percent is that? 19 is the lower quartile. So how many percent is at 19 seconds or more? 75%. 75%. That is your answer for 1 mark. Please don't forget that. Right, from which group, the girls or the boys, did a larger number complete the puzzle in less than 23 seconds? Right, where is the 23 seconds here? For what? For the boys. It is the median. It means 50% is below the 23 seconds, and then 50% is above 23 seconds. And then if you look at the girls, the 23 seconds is here, almost at the what? At the upper quartile. Okay, meaning that 75% is below and only 25% is above 75. Okay, right, we haven't answered the question. We're going to go back and read the question. Now we are trying to understand the information that we're given. Right, from which group, the girls or the boys, did a larger number complete the puzzle in less than 23 seconds? So for girls, all this from here up to there, they completed in less than 23 seconds. Means 75% of girls completed in less than 23 seconds, and only 25% completed after 23 seconds. But for the boys, it's 50-50. 50% finished before 23 seconds and 50% finished after 23 seconds. Okay, so which one is got a larger number? It should be what? It should be girls. 75% of 19 is bigger than 50% of 19. Okay. A learner did a project on climate change. You know the climate is changing. Okay, right. At 1400 hours each day, so it means each day he was checking the temperature. She recorded the temperature in degrees Celsius, because there are other units for temperature, like degrees Fahrenheit, for a certain time. The information is given in the frequency table below. Right, I want us to understand. I want you to discuss for 1 minute. Discuss this information and even discuss the table. Even if you want to extend it. Okay, right, let's try that for 1 minute. Welcome back, grade 10s. Did you manage to discuss? I really hope so. Okay, let's see. What do you understand by this? What is this? 20 what? Degrees Celsius to 24 degrees Celsius. It means the learner was recording temperature. And in 2 days, the temperature was between 20 degrees Celsius and 24 degrees Celsius. And then what is the meaning of this? It means 20 degrees Celsius is part of this class interval. So it means it's included, but 24 is not included. It's going to be included here in this next one. So if it was going to be 24 degrees Celsius, we're not going to count that day. We're going to count it as what? As the second class interval there. Okay? So take note of that. So now it means in 2 days, the temperature was what? Was between 20 and 24. And it does not mean that these days were following each other. No, 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 no. No. It could be day 1 and day 30. But in this month, there were 2 days in which the temperature was between 20 and 24. There were 4 days in which the temperature was between 24 and 28. There were 9 days in which the temperature was what? Between 28 and 32. There were 5 days in which the temperature was between 32 and 36. 7 days in which the temperature was between 36 and 40. Then 3 days in which the temperature was between 40 and 44. Okay. But now, how many days in total? So you're adding all these days. 2 days, 4 days, 9 days, 5 days, 7 days, 3 days. And then you get that is what? It is 30 days. It is 30 days. Okay. Now you've understood the information before even going to the question. Now let's look at the question. How many days did the learner collect the data? We've talked about it. You add all this, 30 days. Done. 30 days. And then let's go to the next question. Write down the model class for the data. Write down the model class for the data. Let's do that in 30 seconds. I'm not going to go anywhere. I'll just wait for you. 30 seconds. Write down the model class of the data. What is it? Right, welcome back. Which one is the model class? The one that appears most with the highest number of items, which is 28 to 32. So it's 28 degrees Celsius to 32 degrees Celsius. 28 being included, but 32 not included. So that's the class interval there. Okay? Right, in the next activity, I want you to try this. I want you to estimate the mean of the data. The mean for this data. You can discuss if you can. Right, it's 3 marks. So I'm going to give you 3 minutes. Right, let's find the mean for this data for 3 minutes. Let's try that. Right, welcome back, grade 10s. I gave you a lot of time so that you can try this, okay? How do we find the mean for group data? This is grouped, okay? It's grouped because we have 20 to 24, 24 to 28, 28 to 32, like that. How do we find the mean? How do we find the mean? Okay, so now because we don't know if these two, is it 20, is it 20, is it 21, is it 22, is it 23? We don't know. If you look at this class interval, we just know that it is between 20 and 24. So that's why the question will say estimate. We are estimating here because we don't know. If we knew that in these two we have 21 and 22, it was going to be easy for us. And then if we knew here maybe the four of them, the other one is 24, 25, 26, like that, it was going to be easy because we're going to add all those things and then divide by 30. But now this data has been grouped. Okay, so we have to estimate. So how do we estimate? How many days are in this class interval? There are what? There are two of them, isn't it? Okay, there are two of them. So we assign them the value of the midpoint of the class interval. Okay, so what's the midpoint of between 20 and 24? That's 22. You see that? It's like we have 22, 22. Okay, and then we go to the second class interval. The midpoint is 26. It's like we've got 26, how many of them? 4 of them. Like 22, 22, 26, 26, 26, 26. We're estimating. We don't know whether it's 26, 27. So we're taking the midpoint. So that's the importance of that. Understand why you are using the midpoint. We are estimating. Okay, so the midpoint here is what? Is 30. The midpoint here is 34. The midpoint here is it 34? 38. The midpoint here is 42. You see that? Now, how many 22s? 2 of them. How many 26s? 4 of them. How many 30s? 9 of them. How many 34s? 5 of them. How many 38s? 7 of them. How many 42s? 3 of them. You see that? After explaining this thing for a long time like this, then you fail it in the exam. Huh? Okay, we are going to fight. Right, now, what do we do? Instead of saying 22 plus 22 plus 26 plus 26 plus 26, what do we do? We just say 2 times 22 plus 4 times 26 plus 9 times 30 plus 5 times 34 plus 7 times 38 plus 3 times 42. Okay, you have added all the 30 items divided by 30. Can you try to put that in the calculator and tell me what you're getting? What did I get? Let me check. I got 32.67 degrees Celsius. Are we getting the same answer? This is how you get your mean from the group data frequency table. Okay, don't forget that. And then the other thing you must remember, the cumulative frequency one. Okay, let me just have a table here so that, because here we are revising, okay, anything can come out. So you're just doing as many things as we can. So let's say this is the cumulative frequency. Cumulative means what? Means you're what? You're adding, you're adding, you're adding. So the first one is 2. Add 4 to 2, what do you get? 6. Add 9 to 6, what do you get? 15. Add 5 to 15, what do you get? 20. Add 7 to 20, what do you get? 27. Add 3 to 27, what do you get? 30. Do you see that we're getting the number of what? Of learners, which is 30. That is cumulative frequency. You keep on adding. Like when you're building, you keep on adding bricks, it continues going up. Okay? Right. Calculate the percentage of days on which the temperature was at least. You see, this thing keeps on coming up. these terms, at least, at most. So at least 28 degrees Celsius. So it means 28 degrees Celsius or more. So where do we start? Here. 28 degrees here is included. So it's part of these 9 here. So there's this 9, there's this 5, there's this 7, there's this 3. Okay? So you say 9 plus 5 plus 7 plus 3, what is it? 9 plus 5 plus 7 plus 3 is equal to what? 24. Okay? Is equal to 24. So now, let's look and check if you have answered the question. Calculate the percentage. Okay? Not the number of days, the percentage on which the temperature was at least 28 degrees Celsius. So it means it's 24 days where the temperature was what? 28 degrees or more out of 30. Then how do you convert that to a percentage? Just think about your marks. You get 15 out of 20. What is that as a percentage? You just say 15 over 20 times 100. Okay, times 100. Okay. Some people put percent, but don't forget that you don't put it in the calculator. Just say times 100. You can just write it if you want. Okay, and then you must get 80%. So 80% of the days of this month, the temperature was above what? 23 degrees Celsius. Okay, it was what? This month was very, very hot. Do you see that? Okay, right. Let's move on to the next question. In the diagram below, now we've done statistics. I think we've covered some questions that are very, very common in the examinations. Okay, very, very common. So now you can look for past papers after this and try to answer the questions which are there. Now this one is analytical geometry. What comes to your mind? The gradient. What comes to your mind? The distance. What comes to your mind? The midpoint. So we're going to be using these 3 formulae. And then also you must know the gradient of perpendicular lines. If you multiply them, you get -1. Okay, they are negative reciprocals. Gradients of parallel lines are equal. Remember those things. Okay, right, now let's read together. In the diagram below, P is 7,4. Do we have 7,4? Yes, it is there, here. Q is 6,6. Yes, it is there. R is 0,3. Yes, it is there. And S is TK. Yes, it is there. You see that? You are checking if all the information is on the diagram. Are the vertices, in the diagram below, P, Q, R, S are the vertices of quadrilateral. It means they can ask us anything here. These people are saying quadrilateral. They can ask us about a rectangle. It can be about a parallelogram. It can be about a kite. It can be about a rhombus. You must know all the properties of those things. So there's something about the quadrilaterals here. Okay, PQRS. Okay, now let's go to the first question. Calculate the length of PQ and leave your answer in said form. Right, I'm going to give you 2 minutes. Try this. This for the distance, gradient, and midpoint. I want you to try the questions before I give you the answers. Let's start with the distance. Okay, once you do one distance on your own, the rest I will just explain. Okay, let's start with this one. Calculate the length of PQ. Let's try. I said 2 minutes. Welcome back, returns. Welcome back. Welcome back. Let's continue with our lesson. Right, now, don't be afraid to highlight or write on the question paper. PQ, where is PQ? PQ is here. Right, we want to find the distance PQ. Right, how do we find that? We're going to use what? The distance formula. So PQ, even if you start with the Q values, it's still fine, okay? Right, it's okay. So it's equals to the square root of what? XP minus XQ squared. Okay, even if you're using x2 minus x1 squared, it's still okay. You're using xb minus xa squared, it's still okay if you, as long as you know what your xa is, what your xb is, or what your x2 is, and what your x1 is. Right, and then plus yp, I'm maintaining that order where yp minus yq, right, squared. Okay, right, now you see, and then let's substitute our values here. Right, pq is equals to the square root of, right, xp is 7 here, this is 7 here. Let me change the color there so that it's a bit different. Where is it now? Okay, yeah, this one 7 is there, so we have 7 minus, and then xq is this one here, so it's going to be 6 and then squared. Do you see that? And then we have plus, where is yp? 4 here, so it's going to be 4 minus 6 squared. And then you can put this thing in the calculator as it is. You don't need to simplify things any further. But let's say you want to, you can. PQ is equal to the square root of, what is 7 minus 6 is 1 squared, plus what is 4 minus 2? 4 minus 6 is minus 2 squared. And then you can get the square root of 5. Square root of 5. Okay, PQ. Remember that. We're going to use that later. So PQ is the square root of 5. This one is square root of 5. You found that, okay? Right. Now, if T, which is 7 over, the coordinates of T are 7 over 2, 7 over 2, is the midpoint of QS, draw your lines. Draw the line QS if it's not there. Right, determine the coordinates of S. Right, so now this is the diagonal QS. And then they're saying T is the midpoint. T is the midpoint, which is 7 over 2, like 3,5, 7 over 2. Right, so what are the coordinates of S there? I'm going to give you 3 minutes. Like I said, for gradient, we have done distance. Now we're using the midpoint formula, okay? The next one maybe will be gradient, okay? So I want you to try these 3 before I explain them. And then the other ones that involve distance now, I'll just explain. After this, the other one that involves the midpoint, I'll just explain, okay? Right, let's try this for 3 minutes. Welcome back, returns. Let's see the midpoint. Okay, right now, how do we find the midpoint? How does the midpoint formula look like? Right, our midpoint in this case is t, so I'll write t, and then t, and then x q plus x s over 2. This gives us the x coordinate of the midpoint, xq plus xs over 2. Right, even if you use xa plus xb over 2 is still okay. x2 plus x1 over 2 is still okay. Okay, as long as you know which one is which. Right, we go to the y1, yq plus ys over 2. Okay, that is our y coordinate of the midpoint. Okay, right, now if you check, our t is given that it is 7 over 2 and 7 over 2. We are given that. So meaning that this and this, these two things are equal. Okay? Right. Meaning that these two things are equal. You see that? That's what it means. So we can equate these two things. We can even work with them separately. Right, let's start with the x coordinate of what? Of the midpoint. Right, let's start with that. So it's going to be, what is xq? Oh, let me write it nicely first. xq plus xs is equal over 2 is equal to 7 over 2. You see that? And then what is xq? It is 6 plus, and then t, okay, over 2 is equal to 7 over 2. You see that? Okay. Now to solve the equation, to get rid of the denominator, multiply by it. Those who know how to cross multiply. So if you do that, you'll end up with 6 plus t is equal to 7. And then t transpose is equal to 7 minus 6. So t is equal to 1. See that? T is equal to 1. So here we have 1 here. Okay. Right. And then, remember root 5. Like the information that you get, you always write it. Write it on the diagram so that if you have to use it for the next questions, it doesn't give you problems. Right. And then we go to the y coordinate. The y coordinate, we're saying yq plus ys over 2 is equal to 7 over 2. Again, the same thing. Multiply everything by 2. Let me just do that so that if there's someone who did not understand that part, maybe they will understand. So I say yq plus, let me substitute first. Yq is what? Where is it? 6. So it's 6 plus k here, this k, plus k over 2 is equal to 7 over 2. And then you multiply both sides by what? By 2 to get rid of it. So this is times 2. This is times 2. Then 2 divided by 2 is 1. 2 divided by 2 is 1. You remain with 6 plus k is equal to 7. Then transpose. And then k is equal to 7 minus 6, meaning that k is equal to 1. So the coordinates of S is, or the coordinates of S are 1, 1. The x coordinate is 1, the y coordinate is 1. You've used your midpoint formula. Okay? Right, let's continue with our lesson. The coordinates of S are 1, 1. Remember, we have 1, 1 here, and then we have root 5 here. Okay? Show that PR is equal to QS. If the coordinates of S are 1, 1, is confirming our answer. Do you see that? Show that PR is equal to QS. Now, what are you going to use here? The distance formula. The distance formula. Okay, let's do it together because we've done the distance formula before. So let's start with PR. Where is PR? No, we have to draw PR so that you can see what we're talking about. This is PR. And then QS we have. See that? I'm drawing my diagram so that I know what I'm talking about. Right, let's start with PR. So P is going to be PR is equals to, let me substitute the values straight away. We don't need to wait. So let's start with 7 minus 0. So it's going to be 7 minus 0 squared plus 4 minus 3. Right, 4 minus 3 squared. Okay, what is 7 minus 0 squared? And then 4 minus 3. Okay, let's see. Right, it's going to be, you can use your calculator, but let's say you don't have a calculator. 7 squared is 49. Then 4 minus 3 is 1. 1 squared is plus 1. So it means PR is the square root of 50. Okay, PR is the square root of 50. Okay, like this. Now let's do which one? QS. This one. Okay, so QS equals to, let's say, 6 minus 1. So it's going to be square root of 6 minus 1 squared plus 6 minus 1, 6 minus 1 squared. Right, what is 6 minus 1 squared? That is 5 squared, isn't it? So it's going to be QS is equals to 25 plus 25. So QS is equal to square root of 50. Therefore, PR is equal to QS, and then both of them are equal to square root of 50. You see that? So they are equal. We have proved that. Okay, we have proved that. Show that PR is equal to QS. Right, don't forget that. So this one here is root 50. Right, we leave it like this. Remember, this is like square root of 2 times 25. Okay, so what's the square root of 25 is 5. So this is 5 root 2. That's the thing. That's the answer there. 5 root 2, not okay, 5 root 2. Okay, leave it in set form. So it's 5 root 2, not 5 root 20. Okay, right. Show that QR is perpendicular to RS. Now we are going to use the gradient formula. So now I've given you time to try the distance formula. I've given you time to try the midpoint formula. Now I'm going to give you 4 minutes to try the gradient formula. Let me give you a clue here. Okay, it's 4 marks, isn't it? So don't stress. You must know what you're supposed to do. When you get a question like this, you have to find the gradients. Find the gradient of QR, find the gradient of RS, and then after that, I won't tell you what you're supposed to do. You have to try it on your own, okay? Right, 4 minutes. Let's try. Welcome back, grade 10s. Let's do our mathematics and see if we manage to get the right thing. When the lines are perpendicular, what do you know about their gradients? The product of their gradients is -1. If you multiply their gradients, you'll get if I say minus -1, it would be negative, isn't it? Right, if you multiply their gradients, you'll get -1. Actually, the gradients of perpendicular lines are negative reciprocals of each other. If the gradient of the other line is 3/4, and then this line is perpendicular to the other line, that other line should be -4/3. They are negative reciprocals of each other. If the other one is 2, the other one is going to be -1/2. Because 2 is like 2/1. Don't forget that. It's very, very important. You will get a question about the gradients of perpendicular lines. You will get that. Distance, gradient, midpoint. You will get questions about that. Okay? Right. Now, so we need to find the gradient of QR. We need to find the gradient of QR. And then we find the gradient of RS. And then we have to see if these two lines are perpendicular to each other. So MQR, the gradient of QR, how do we find it? Okay, what did I do here? We say the change in y over change in x. So it means YQ minus YR over XQ minus XR. Okay, then you get your gradient. Even if you say YR minus YQ over XR minus XQ, you will get the same answer. Now you know that, isn't it? So MQR is equals to 6 minus 3. 6 minus 3 over 6 minus 0. 6 minus 0. Right, what is 6 minus 3? It is 3/6, which is 1/2. That is the gradient of QR. That is the gradient of QR. You see that? So it means the gradient of RS must be -2 if they are supposed to be what? To be perpendicular to each other. Let's see. Right? So we say MRS. So it's going to be R. Let's start with Y. 3. What am I doing? Oh, this one is 1. You forgot that. I almost forgot that. I was sweating now, thinking, what is this? Now, 3 minus 1. Oh, let me write the formula first. YS, or this is YR minus YS over XR minus XS. Right now, so it's going to be MRS is equal to what? 3 minus 1. 3 minus 1 over what? 0 minus 1. 0 minus 1. So what is the answer there? MRS is equals to 2 over -1, which is equal to -2. Do you see that? And then half times -2 is equal to -1. So therefore, what? QR is perpendicular to RS. You see that? Because the gradient of what? QR times the gradient of RS, it gives us what? -1. Or the gradient of QR is a negative reciprocal of the gradient of RS. So this is a right angle. We've proved that. You see that? So remember that. And then remember the sides. Okay, we need them. When you need them, we'll remember them. Our sides there, remember we've got √5 there. And then for this side, we got what? It was 5 root 2. And then now we've discovered that this one is what is a right angle. So every information that you get as you calculate, make sure that you put it on a diagram, because you're going to use it in the next questions. Hence, you see that? What does that mean? Hence. And then this one says hence. It does not even say hence or otherwise. No, it says hence. So it means use the answer you got to answer this question. Hence, what type of special quadrilateral is PQRS? Motivate your answer. So the 2 marks here. What is it and why? Right. Remember, we proved that QS is equals to PR. We proved that. And then we proved that this one is a right angle. Okay. So when the diagonals are equal, what type of a quadrilateral is it? When the diagonals are equal. And now on top of that, we have a right angle here. So what type of a quadrilateral is it? It is what? A rectangle. It is a rectangle. Okay, it is a rectangle. Why? Because the diagonals are equal to each other and we have a 90-degree angle. Okay, so it's a rectangle. So calculate the size of RSQ. Let me just highlight that angle here, which is this one. Okay, right, which is this angle here. Right, so we're going to look at this. Now we know that this PQRS is a rectangle. So if this side is root 5, it means this side is also root 5. Okay? This side is 5 root 2. Now we need to find this angle here. What do we do? What do we do? Okay? Right. Now, which trig ratios can we use? Remember now, integration of what? Of topics. Right, we are dealing with analytical geometry. Now we're supposed to find an angle. We have to use our trig. Remember, so, ka, to, wa. Right. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. So I'm using theta as our variable for the angle. I can say sine x, but I can just say sine. Sin. I've seen people writing sin. There's nothing like that in mathematics. It should be sine something. Sine x, sine a, sine theta. Okay? Right, now, if you look at this angle here, which sides do we have? We have adjacent. This is 90 degrees. And then we have the hypotenuse. So which ratio involves hypotenuse and adjacent? It is the cos theta, or the cos A, the cos x. Okay, so now we can use that. So cos RSQ right is equals to a adjacent over hypotenuse. So it's going to be root 5 over 5 root 2. Okay, and then how do we find the angle? How do we find the angle? Remember that. So RSQ is equals to arc cos inverse. So you go to your calculator, right? You say shift and then you press cos. You see something like this, cos, okay, like this. And then you can enter your root 5 over 5 root 2 there, and then close the bracket and then equal sign. Okay, so now put this there. Okay, then close the bracket nicely and then press equal sign. What do you get? Let me do it. We have, I use the fraction function a lot, so square root of 5 over 2 root 5 root 2. I move my cursor to the side, then close bracket. Okay, right, and then what do we get? We get 71.57, because 71.565. So because of rounding off, you get 71.57. How many people got that? Please make sure that you do that and get 71.57. So this is root 5 over 5 root 2. And then you get that RSQ is equals to 71.57 degrees. Okay, that's the size of the angle. So now think about the integration of topics. Please remember that. Triangle PQR and triangle SQR. Make sure that you see those triangles. Are right angle triangles. Do you see the right angles? As shown in the diagram below. PR is 26. So, okay, here. They're saying PR is 26, but they didn't write it down. So let's write here. 26. Okay. PQ is 24 is given. QS is 8 is given there. RS is 6 is there. QR is 10 is there. And then PRQ is theta, it is there. So we have all the information. Let's remember the 26 every time. Okay? Right. And then let's go to the question. Remember there's 26 here. What is tan angle P? Using the diagram, what is tan P? I'm going to give you 1 minute. Let's try. Well done, grade 10s. Let's see if you manage to get the answer. Tan P. Highlight the triangle. Highlight the triangle. So now, this is a triangle PQR, which is angle P, which is this one. You see that? Now look at the size of this triangle. Right, tan P. Go back to SOHCAHTOA. Write it down. Write it down. SOHCAHTOA. Write it down. Right, now if you look at this side, tangent is opposite over adjacent. So this is the opposite side. If you look at this one, this is the opposite side. And then adjacent, just next to the angle there, that's 24. You see that? So the opposite is 10, the adjacent is 24. So now it is opposite over adjacent. So it's going to be 10 over 24. Okay, so tan P is equal to 10 over 24, and then can be reduced. Even if you put it in your calculator, just say 10 divided by 24, you'll get what? 5 over 12. Okay, so that's the answer there. Okay, right. Let's find sine SQR. Find sine SQR for 1 minute. Let's try that for 1 minute. Right, welcome back, greetings. Let's see. Let's highlight our triangle that involves angle SQR. This is the triangle. Where is angle SQR? You see, I'm highlighting so that can assist me. Now, sine theta, sine SQR. Sine, okay, so katone. So it means opposite over adjacent. Now, which side is opposite? What did I say? Opposite over hypotenuse. Okay, this side is opposite, that is 6 there. Where is the hypotenuse? People will confuse there and say QS is the hypotenuse. No. The hypotenuse is opposite the 90-degree angle. Okay, so this is the 90-degree angle here. So the hypotenuse is opposite that angle. So the hypotenuse always opposite the 90-degree angle. Please take note of that. And then so it means now the sine SQR is 6 over 10. And then sine SQR is equal to 6 over 10. Let's reduce that to 3 over 5. So that is sine SQR. Right, let's do another one. I've got 4 of them that I want you to do. I'm going to give you 1 minute to 1 minute. We're left with 2 now. Okay, the next one. Right, cos theta. Cos theta. Right, 1 minute. Let's try. Welcome back, returns. Let's see. SOHCAHTOA. I still use this a lot. SOHCAHTOA. Right. Cosine. Cos theta is adjacent over hypotenuse. So which triangle are we talking about here? This is the triangle where there's angle theta here. Okay. So which side is adjacent? This is the side which is adjacent. Adjacent means next to. And then hypotenuse, opposite the 90-degree angle. So that is that, which is 26 here. So cos theta is going to be 10 over 26. Okay, what happened there? So cos theta is going to be adjacent over hypotenuse, 10 over 26. It reduces to 5 over 13. Do you see that? Okay, right. Now let's move on. By making reference to the above diagram without using a calculator, write down the value of sec SRQ. Sec SRQ. Another minute. I almost said 2 minutes, but we can do this in a minute. Let's try. Welcome back, returns. what are the reciprocal ratios? The reciprocal ratio for tan theta, what is it? Tan theta is what? Cot theta. Then sine theta, what is it? Cosec. The people confuse this one a lot. They think that the reciprocal of sine theta would be sec, and that one of cosine is cosec. Ne? So for sine theta is cosec theta, and then for cos theta is going to be sec theta. Okay, right, these are the reciprocals. Okay, right, we can go back to our SOHCAHTOA and what, and use it to answer such questions. Right, SOHCAHTOA. Okay, let's deal with the sec. Sec is the reciprocal of what? Of cos theta. Okay, so in this case, reciprocal of cos SRQ. So now the reciprocal means that it's going to be 1 over cos SRQ. That's what it means. Okay, so it means we are dividing 1 divided by cos SRQ. 1 divided by. And then this one is opposite, is adjacent over hypotenuse. So it's 1 divided by adjacent over hypotenuse. So now remember we tip in times. So it becomes 1 times hypotenuse over adjacent. So that's the reciprocal. The reciprocal goes around. So like SOHCAHTOA, sine theta is opposite over hypotenuse. The reciprocal of sine theta is hypotenuse over opposite. Cos theta is adjacent over hypotenuse. The reciprocal of that is hypotenuse over adjacent. Tan theta is opposite over adjacent. The reciprocal of that, which is cot theta, is going to be adjacent over opposite. Just do that, you're done. Okay, so now if we check which triangle are we talking about, that is SRQ. This is the angle here, SRQ. Sec is hypotenuse over adjacent. So the hypotenuse is here, which is 10, and then the adjacent hypotenuse, let me use this, hypotenuse is opposite the right angle, and then adjacent just next to. Okay, so it's hypotenuse over adjacent, so it's going to be 10 over 6. Okay, that's the answer, which is 5 over 3. Okay, this is the opposite of cos. Sometimes just do this. Find cos theta and say cos SRQ is equals to 3 over 5. And then you say the reciprocal of this is going to be sec SRQ is equal to 5 over 3. Just that. You can work it from the original what? Ratio. And then you just tip it. You tip the numerator becomes the denominator becomes the numerator. Then you can find what? Your reciprocal ratios. Right. Let's move on. Calculate without using a calculator the value of cot theta divided by cosec QRS. I want you to use 3 minutes trying to answer this question. Then after 3 minutes, we'll discuss. Let's try. Right, welcome back, cretins. Okay, I'll use SOHCAHTOA to be fast. Okay, right, let's say SOHCAHTOA. Right, so tan theta is opposite over adjacent, therefore cot theta is going to be adjacent over opposite. Now let's look at our angle, reference angle here. So this is adjacent, this is opposite. So it means since tan theta is going to be 24 over 10, opposite over adjacent, so cot theta is going to be adjacent over opposite. It's going to be 10 over 24. So cot theta, I'm repeating the same thing, I'm wasting time. Right, okay, QRS. So it's going to be, we said adjacent over opposite, so it's going to be 10 over 24. Right, 10 over 24. Okay. Right, when I'm dividing, I usually draw a longer line so to show that I'm dividing fractions there. Right, and then cosec. Cosec is the reciprocal of sine theta, sine QRS. Now let's look at this triangle here. This is sine, okay, sine, and then sine is opposite over hypotenuse. So it's going to be hypotenuse over opposite. So if you look at this angle here, this is opposite the angle, then this is the hypotenuse. You see that? So it's going to be hypotenuse over opposite, which is 10 over 8, which is 10 over 8. And then now, when I'm dividing fractions, I find it easier to do like this. I'm not sure if it's going to assist someone also. Divided by 10 over 8. I write fractions like that. And then now, when I do this, I know what I learned even in primary, that I must tip in times, okay? And then it becomes very easy for me to apply that. And then times 8 over 10. 10 into 10, 1. 8 over 24 here. What's the highest common factor? It should be 4. It should be 8. Okay, 8 into 8, 1 into 24, 3. So it's called 1 over 3. Okay, done. You must show your calculation. You must show all the steps because it says without using a calculator. So show all the steps. Okay, if you don't show the steps, you'll lose marks. Where it says without using a calculator, show the steps. Don't just write the final answer. Okay, in the diagram below, PXY is a point in the third quadrant. Do you know the quadrants? 1, 2, 3, 4. Right. ROP beta. Okay, so now we know that this angle ROP is angle beta. And 17 cos beta plus 15 is equals to 0. Understand the diagram before you do anything. In the first quadrant, both x and y are positive. Positive, positive. R is always positive. All the quadrants, R is positive. In the second quadrant, X is negative. And then Y is positive. In the third quadrant, both X and Y, negative, negative. And then in the fourth quadrant, X is positive. And then Y is what? Negative. Remember that. So in the third quadrant, it means for X you must get a negative value, for Y you must get a negative value. Okay? Right. Now we're given this. Try to work on your diagram before even going to the question. So now when it is like this, we can't see the ratio. The ratio usually is expressed as a fraction. So let's create a fraction from this. And then make cos beta the subject of the formula. So now we transpose, bring 15 this side, becomes 17 cos beta is equal to negative 15. Then divide by 17 both sides. So cos beta is equal to negative 15 divided by 17. Okay. So cos beta or cos theta, do you know that is x over r? R is always positive. Okay, so now before you do anything, you must know. So it means here r is 17 and then x is negative 15. Okay, right, let me pick another color. Right, this is 17, this is negative 15. Okay, right, now we need to find y before you do anything. So now we know that r squared is equal to x squared plus y squared. You know this is coming from the Pythagoras theorem. Right, now r squared, so it's going to be 17 squared is equals to negative 15 squared plus y squared. So 17 squared minus 15 squared is equals to y squared. What is 17 squared minus, let me do it with my calculator. 17 squared minus, let me just say 15 too, so I don't waste time. 64. 64 is equal to y squared. So what will be y? Is going to be plus or negative, positive or negative 8 is equal to y. So is it going to be negative 8 or positive 8? We said both of them in the third quadrant are negative. So it means this one is negative 15 and negative 8. We have found our x, our y, and our r. Then you can start answering your questions. Don't rush and go to the question before you fill in all these the three variables, x, y, and r first. And then you can what? You can then start answering questions. Okay, let's go to the questions. Now you know what we got for x, you know what we got for y, you know what we got for r. Right? If you do not get that, please try to do on your own. It's 4 marks. This is 4 marks. So I'm going to give you, I've done something with you, so I'm going to give you 3 minutes. Okay? Oh, no, we don't need 3 minutes here. What is the value of x, y, r? We've done that. So it means x, we said x is negative 15. Y is negative 8. R is 17. Okay, we've done that part. So now remember this, okay? Remember that. Right. Without using a calculator, determine the value of sine beta. 1 mark. Okay, 1 minute. Let's try. Welcome back, returns. What did you get for sine beta? Right, some people still use the opposite SOHCAHTOA thing. It's still okay. But remember that I'll use sine, okay, let's use beta because our angle is beta. Sine beta is equals to what? In terms of x, y, and r. It is y over r. Remember that. And then cos beta is x over r. And then what about tan beta? Tan beta, it is y over x. Y over x. Remember that, okay? But sometimes we do use this, draw a triangle. Okay? Remember, always draw to the x-axis. Never draw to the y-axis, okay? This line to the x-axis. And then, like here, you have minus 15. Here we have 17. Here we have minus 8. Negative 8, negative 15 there. Right, and then they can use SOHCAHTOA with that. It's still okay. Okay, but remember, for trig ratios on the Cartesian plane, we use that. Okay, and remember that r squared is equal to x squared plus y squared. We use that a lot. So sine beta is going to be y over r. What is our y? It is negative 8, r is 17. So it's going to be negative 8 over 17. That is sine beta. In the third quadrant, okay, sine beta is negative. Okay, right, makes sense. Right, let's move on. Without using a calculator, determine the value of cos squared theta. So cos squared 30 times tan beta. Right, we say tan beta is going to be y over x. Well, y was what? Negative 8, negative 15 is going to be negative 8 over negative 15, which is 8 over 15, and then our tan theta in the third quadrant is positive. It makes sense, right? Special angles, you must know your special angles. Say without the calculator. Okay, I mustn't be teaching you this, but you say without the calculator. So just confirm your special angles with your calculator. Just confirm. Don't just confirm. What is cos 30? Okay, cos 30. What happened here? Let me see. Right, what is cos 30? Just confirm. I know cos 30 is root 3 over 2, isn't it? But just confirm cos 30. Do that in your calculator. Root 3 over 2. Do you see that? Now I put my calculator aside. I just wanted to get my special angle. Okay? So now, and then what is the meaning of this? Sometimes it confuses. Okay? Now, it's a convention. You know, convention. Something whereby the mathematicians agree that we're going to write this thing like this because we don't want it to be confusing. So now, if it was like this, cos 30 degrees squared, it's going to be confusing there. What is squared there? Is it 30 or is it cos 30? You see that? So now to reduce that confusion, then mathematicians agreed that this square is going to be between here. That's convention. So now, actually, cos squared 30 is just cos 30 squared, like that. So when you're putting in your calculator, you must make sure you put your cos 30 inside the bracket and then you square that whole bracket. Okay? That's what it means. So now what is cos 30? Is root 3 over 2. So you're going to say root 3 over 2 squared times tan beta. What you get for tan beta? 8 over 15. 8 over 15. Right, root 3 over 2 squared. This squared is going to be 3 over 4. I'm not using a calculator. Right, times 8 over 15. Even here I can write my final answer. No one can say. The 4 into 4, 1. 4 into 8, 2. 3 into 3, 1. 3 into 15, 5. So the answer is 2 over 5. You see, we didn't use a calculator. See that? Okay, done. Right, calculate the size of ROP. Remember, we're told that ROP is beta. So it means we're talking about this angle here. Okay, we're told that ROP is beta. So we're talking about that angle there. So now we can find this angle here. I'm trying to explain now because we're left with roughly 12 minutes. So I'm going to explain everything now. Okay, I won't give you time to do things. Okay, but I'll try to be slow. It's better to understand what you've done. Okay, than rushing and we don't get anything. Right, remember this is negative 15, this is negative 8, this is 17. Right, we want to get this angle here. You can choose any of the ratios that you want to use here. Okay, like I chose, let's choose anything. Let's choose anything. Someone can choose the cos theta, the other one may choose tan theta, someone may choose anything. Right, let's choose. Let me use, which one? Tan. So tan, I want this angle here, this one. The small one, let's call it x. Okay, let's find tan x. Tan x is equal to what? It is opposite over adjacent. This is opposite, this is adjacent. So it's 8 over 15. Okay, and then x is arctan 8 over 15. Let's see that. What do I get? Someone, it's going to be interesting if you use different ratios and seeing if you're going to get the same answer. Right? Arctan 8/15. Right, what do I get? I get 28,0724. So let's do 2 decimal places. So x is equals to 28,07. You see that decrease. Okay, that is this x here. So now we add these two. From here, where is my pen? Right, from here up to there, how many degrees is that? It's a straight line, 180 degrees. And then from here up to there, we're saying it's 28,07 degrees. So now it means we're adding here 180 plus that is going to be 180 degrees plus 28,07 degrees, which is 208, wait, do I get 27? 07, sorry, degrees. That is the answer there. Okay? Right. I want us to do, this one is easy. Okay, this one is easy. So we've done something like this. Just say x is arctan 2,22. You'll find your angle x there. Okay? Right, this one, sec. You have to be careful there. You have to be careful. Right, sec is the reciprocal of cos. So it means 1 over cos x plus 10 degrees is equals to 5,759 over 1. And then you can cross multiply them. 1 is equals to cos x plus 10 degrees times 5,759. Therefore, cos x plus 10 degrees is equal to 1 divided by 5,759. Do you need to do all this? No. Because you know that cos sec is this. So therefore, okay, cos x plus 10 degrees is equals to 1 over, okay, because sec is 1 over cos. Okay, 759. Just like that. That was enough. Then you do your x plus 10 degrees is equals to arc cos, the inverse, 1 over 5,759. And then you get your answer. Let's try that. Let's do arc cos, shift, and then inverse of cos there. Then put the fraction 1 over 5,759. Move the cursor to the right, then close bracket, which is equal to 80 degrees. Roughly, this is 80 degrees. So x is equal plus 10 degrees is equals to 80 degrees. Then what is x? Transpose. It's actually 90 degrees. 80 minus 10 is 70 degrees. Okay? And then this one. Transpose this becomes, let me change color so that it can be, okay, I have slides. Let me move my slides to the front. Let me move them to front, okay, so that we have space. Right, okay, here, transpose, bring this one this side. It becomes sine x over 0,2 is equals to 3,24, isn't it? And then multiply by 0,2 both sides, okay? So sine x is equals to, what is 3,24 times 0,2? 3,24 times 0,2. What do we get? Okay, is 0,648. And then you do the arc sine. X is equal to arc sine. Okay, 0,648. Arc sine means the inverse of sine. Right, and then we must get what? Shift arc sine, then 0,648. Then what do you get? 40,39. You see that you found your x. Okay, that's what it's supposed to do there. Okay, right. Now let's move on. So we've covered statistics, we've covered trigonometry, we've covered analytical geometry. We're still doing trigonometry, but I want us to, in the last 5 minutes, just discuss one question on what? On functions, trigonometric functions. Right, in the diagram below, the graphs of f of x is equal to minus cos x minus 2 cos x is drawn for the interval of 0 to 360. This is our domain, grade 10s. Remember that, okay? From 0 to 360, okay? Then the domain is going to be increased as you go to grade 11. Right, write down the amplitude of f. Remember that. There's this mistake where people just take this and say the amplitude is 2. Yes, it's fine, but for this question it is okay, your amplitude is going to be 2. But let's say this graph was shifted upwards, and then maybe shifted upwards, and then it's like this. Then someone says the amplitude is 3. You see? So that is wrong. Remember the formula for amplitude. It is what? Amplitude? It is what? The maximum value minus the minimum divided by 2. So our maximum value is 2 minus negative 2 over 2, which is 4 over 2, which is 2. So that's why the amplitude is 2. Please use the formula. Don't just look at the graph. It is very, very dangerous. Okay? Write down the minimum value of f of x plus 3. What is the meaning of this? What is the meaning of that? Okay, we have f of x is equals to negative 2 cos x. And then we have h of x, which is f of x plus 3. This is the negative, what? The negative 2 cos x. So it's like h of x is equal to negative 2 cos x plus 3. Do you see that? So it means you're adding 3 to the function. This is like the q. Do you remember that? What is the effect of the q? Vertical shift, upwards or downwards. So if it is plus 3, it means it is going to go up by 3 units. So the minimum value will shift from negative 2 and it becomes 1, 2, 3. So it means the minimum value will become 1. Plus 3 means it goes up by what? By 3 units. Remember that, okay? Remember that. You will be doing f of x plus, you will be doing like this very soon, okay? It's totally different. Né? This is for horizontal shift. But f of x plus 3 like this, shifting upwards or downwards. Whether it's a trigonometric function or an algebraic function, use the same thing. Okay? Plus 3, 3 units upwards. Negative 3, 3 units downwards. Okay? On the same set of axes, to draw the graph of g, where g is sine x plus 1. I know the graph of sine x. I know it by now. Okay? I don't need a table. So sometimes that's what assists me. Okay, like now time is running out. I don't have time for drawing tables and all that. I'll draw the graph of sine x and then shift it upwards by 1 unit. Then I have my g of x. Okay? I know sine x will start from 0. It goes to, at 90 it is 1. At 180 it is 0. At 270 it is negative 1. Then at 360 it is 0. I know those critical values, okay? Now I need to draw my graph that I was asked to draw. They said this, okay? So I'm going to shift this graph 1 unit upwards. So it's going to be like this, okay? And then where is here? It's going to be here. I'm shifting every point by 1 unit. And then here is going to be there. Then here is going to be there. Done. This is g of x. Okay, I'll get my marks here. And then indicate. Okay, this is 0, 1. This is 90 degrees, 2. This is 180, 1. This is 270, 0. This is 360 degrees, 1. Something like that. Indicate your points. Okay, critical points there. Okay, right. Let's see if we can use the last 2 minutes. Use the graph to determine the values of f of 180 degrees minus g of 180 degrees. So where is f? This one is f, ne? 180 degrees. Where is f? It is 1 here. And then g, where is g? At 180 degrees, it is here. So what is the difference between these two? What? Give the answer very fast. What is it? What's the difference? 1 unit. Okay, that's the difference there, the gap between the two. For which values of x will f of x times g of x greater than 0? So when you are saying you're multiplying two things and creating a positive value, greater than 0 means positive. It's either both items are negative or both items are positive. So now if you check here, divide into regions like what you did with algebraic functions, okay? If you check here, this one is positive, this one is below the x-axis, so it is what? It is negative here. And then this one is positive here, positive there. And then here, this one is positive here, this one is below the x-axis is negative. So this, we don't want this because we want greater than 0. We don't want that. Okay, so we want a situation where we say positive times positive or negative times negative. So this is the region we want. And then, so it means our x should be between 90 degrees and 270 degrees. You see that? So that's what you're supposed to do there. Right. The graph of f is reflected about the x-axis and then move 3 units downwards. I'll reflect the graph. I get something like this. That's a reflection. Okay? And then this was negative 2 cos x. So this one is a reflection. It's going to be cos 2 cos x, sorry. Okay? And then we shift it downwards by 3 units. And then we shift it downwards by 3 units. It's going to be minus 3 like that. Okay? So that will be h of x. Okay, right, you can try to replay the video there. I try to move fast there. The range for h, so it means it moved from negative 2 by 3 units downwards. So it should be at minus, this one should be at minus 5 here, or negative 5. Okay, and then up to there. So the range is between negative 5 and negative 1. So it means your range, which are your y values, included. So it's what? Negative 5 to negative 1. That's the range, your y values. The graph exists between negative 5 and negative 1. Okay, right. Can take a picture of this one. It can be your homework. Just take a picture. You can pause the video, okay, and then take a picture. And then you can pause the video here and take a picture, and then you can try to answer the questions. Again, just pause the video, take a picture, pause the video, take a picture like that, and then you can consult, discuss with your colleagues, discuss with mem on say there in the classroom, anyone who can assist you on those concepts, and then you'll be done. Thank you very much. Don't forget to press complete so that we can see that you completed the course. And then after that, we're going to meet again for our next lessons. Thank you very much, grade 10s. Enjoy the rest of your day. You keep safe, sanitize, wear your mask, and you social distance. Let's meet again, grade 10s, when we are going to be doing our lessons. Hopefully, we are going to meet when you're doing grade 11. Thank you very much. Enjoy the rest of your day. Goodbye.